Are you all good so far? I've started recording, I've shared my screen, and also I'm going to continue further with the training now. So are you all good now to continue further?
Yes.
Okay, good. Nice. The very first thing that I'm going to cover is this content for switching. So if you go to cisco.com, everybody knows that you can get a lot of information over cisco.com. Most of the things can be done here or can be searched. Like Cisco has provided all their documentation is and a lot of stuff that they have got on their website. So now if you go to learn tab, right, there's a learn tab and then there should be, learning at Cisco, or maybe you can scroll down a little. You can scroll down a little, and then you should have this option certifications, Cisco validated training, community support, and so and so. Click certifications. Once you click on certifications, then you should have, like, again, you need to scroll down and you would have certifications for all levels and technologies. That's where you would get collaboration and then cybersecurity, data center, design, DevNet, enterprise, and V falls in under enterprise. V, when I say V, which means that we are talking about Encore switching here, right? And Encore switching falls under enterprise. So if you select enterprise option, right, out of this list, and then you would see that you have got a couple of exams like CCNA or maybe entry level exam, which is Cisco Certified Support Technician, and then you also have got the professional level of certification, and then also you have got a expert level certification. Now I'm not talking about the CCIE examination for now. Let's talk about CCNP Enterprise thing. So under CCNP Enterprise, you would see that you have got a exam called like if I talk about the CCNP examination, the very first exam that you need to appear for is the core exam. And in fact, we can look for this information to explore exams and trainings. Just click there, and then once you click on exams and training, then you would get to know that to become CCNP certified, you have to pass the core exam. That's the very first or bare minimum requirement. So you must pass your core exam, and that's where you have got some switching topics as well, or some topics related to Cisco switching. To pass this core exam, I can open that up in new tab, and then you would see Encore exam topics. And for Encore exam topics, you would get to know that under architecture, you have a couple of things there. So, such as network design. Usually, it's part of the switching, like tier two tier, three tier, two tier architecture, fabric, high availability techniques using FHRP or SSO. So that's a switching topic. Usually we cover that stuff in switching, and then we have got the infrastructure. So if you look at the infrastructure, there is a layer two section. Under layer two section, you will get to know that we have to learn that how to perform troubleshooting for trunking, for trunk interfaces or for trunk port. Is usually we use our .1q trunking protocols to enable trunking between the switches. So that's what you're going to learn here, that how to perform troubleshooting just in case if your trunking is not working between the switches. And then you also have got a topic called ether channel. Then you have got a topic called RSTP and MSTP. So they're not talking about the STP anymore. They are talking about rapid spanning tree protocol and then multi spanning tree protocol, which is MSTP. So that's the thing. So they're not talking more about the STP anymore. Why? Because it is never recommended anyone to go with STP. You should go for RSTP. And if STP is by default enabled on Cisco switches, change it to your rapid spanning tree protocol or multi spanning tree protocol or MSTP. So generally nowadays we are recommending our customers to move on to RSTP or MSTP. Not now. It's been so long time. It's not something new. It's pretty much old. So that's layer two. And that's what you cover under switching. Now, if you look at the topics that you need to cover, and there are a couple of more, like first hop redundancy protocols like HSRP, VRRP. And Cisco has excluded GLBP. You don't see GLBP here, and there is a specific reason because Cisco does not want us to learn about GLBP anymore because they are not using it. Like most of the time, we are using only VRRP, and then in few cases, you would see that we are also using HSRP. So if you are using Cisco devices only, then you are using HSRP. But if you are using non-Cisco devices, then you are relying completely over VRRP because VRRP is the open standard protocol, whereas HSRP is a Cisco proprietary protocol. So that's the another topic that usually we cover that under switching. And yeah, I mean that's what we are going to cover. So just to cover only these few topics of the Encore exam, we have to cover now the entire switching. However, now there is a twist. Like this is an core exam, and this core exam also works similar to like your CCIE written exam, or it is a prerequisite exam for CCIE lab examination. So whether you are trying to attempt your CCIE lab over enterprise infrastructure or CCIE enterprise wireless certification, doesn't matter. Attempting and clearing 350-401 in core exam is mandatory. So clearing this exam is mandatory. So having an core exam or passing an core exam is really important, is really needed. Okay. Now, if I go back to CCIE examination, so let me go back here, not to CCNP level examination. In fact, I would like to go for the CCIE lab examination. So just a moment, please. I'll have to go back. And then under CCNP, okay, I have to go back once more. Yep. So under enterprise, then I shall have an option for CCIE also, not for wireless, but for enterprise infrastructure. So if you click on CCIE enterprise infrastructure, then you would get to know that you could look for explore exams and training. So you could look for exams, explore exams and training. And then once you click there, then you would get to know that pass two required exams to become CCIE. First, you have to pass your ENCOR exam. That's much needed, or I would say that's a mandatory step to attempt your CCIE lab. And once you clear this lab examination after your core exam, then you become CCIE. You could look at the total cost that you need to bear, you need to pay to Cisco to attempt these two exams. One of them is the ENCOR exam, and the total cost is USD 400. And for lab exams, the exam cost is USD 1600. The total duration for lab examination is 8 hours, whereas for ENCOR it's 2 hours. So generally for ENCOR exam, you don't have to go anywhere. You can attempt your exam online. Like if you are booking your exam onto Pearson View testing center, they will allow you to attempt your exam online. You can attempt this exam from your home itself, but for attempting your lab examination, you have to go to Cisco centers. So only on Cisco centers or validated Cisco testing centers you would be allowed to attempt your lab examination. And I believe around the world there are only 7 or 8 testing centers, or maybe 10 testing centers, not more than that. Other than that, like they have got some sort of mobile test centers that they open just in case if they get exam bookings, then they can open up the mobile test center, and then they close it once they think of not having too many candidates attempting exam. So I'm not talking about the mobile test facilities. I'm talking about the fixed permanent test centers provided by Cisco. So obviously, like there are 8 to 10 centers. In United States, there are 2 or 3. Probably, again, you can go to their portal and then you can look for that in which all cities, in which all states and countries they have got their testing centers. But yeah, to attempt your CCIE Enterprise Lab examination, you must clear this ENCOR exam. Now, here is the interesting thing that if you are looking to attempt your CCIE Lab examination, and if you look at the exam topics, then first look at the network infrastructure, and then you will get to know that they have so many topics around steep and about the Ethernet switching or Cisco switching, like managing MAC address table, array disabled recovery, layer 2 MTU, CDP, LLDP, UDLD, then access ports, trunk ports, native VLAN, manual VLAN pruning, normal range, extended range of VLANs, voice VLANs, LACP, static ether channel. Now they're not talking about the PAGP if you look at here, right? Which means that Cisco is slowly now removing PAGP from their content. And in fact, I would say that they have removed it because it's not really recommended to implement PAGP. Yes, if you have got Cisco devices at both ends, fine. You could use PAGP, you could still use PAGP, but generally it's recommended to use either static ether channel or LACP. Then you have got layer 2 ether channel, layer 3, and then load balancing for your ether channel, then is ether channel misconfiguration guard, and then identify multi-chase ether channel use cases, like where you could really leverage this feature called MEC or multi chases ether channel. So sometimes we call it MEE for ether and C for channel. Multi-chase ether channel, MEC. They've also added your spanning tree protocols such as PVST plus, rapid PVST plus, and MST. So, like if you look at the core exam, they don't have this PVST plus there. They have got only rapid PVST, and then they have got MSTP there. They don't have PVST plus. But if you look at here, you would see that even PVST is also available, right? And then switch priority, port priority, tuning, port path cost, STP timers, port fast feature, BPDU. So pretty much like all topics are here when it comes to the switching. So now, if you all are enrolled for CCIE training, I don't, or we don't want, being a technical person, I don't want you to cover like first Encore based switching and then CCIE switching. No, we have clubbed these switching topics together, and then that's what we are going to cover here. So the objective of this training with me is to cover all the topics that Cisco has added for their CCIE lab examination as well as for their Encore exam. So that's what we are going to cover during this training with me. So I'm responsible to cover all the switching topics here. If anybody has any questions, don't hesitate to ask those. No?
Yeah, thank you, sir. So, oh yeah, this is Burhan. I joined late. So, yeah, this was my question because I enrolled for CCIE, but it's good to you already mentioned it that you are covering both Encore and also CCIE
Yeah.
switching
Yeah.
here. That's good. All right.
Okay, cool. So we have already gone through the topics that we are going to cover during this training. Now it's time to get started further. So now most of time, let me just connect myself to the VPN, please. All right, I'm connected to the VPN now. I shall have access to the labs. Okay. So generally, I cover my switching topics using this single lab. So if you look at here, there are 4 switches in this diagram. There is a full mesh inter-switch links or inter-switch connectivity if you look at here. So all switches are interconnected in full mesh topology, and pretty much we can perform everything, all the labs that we needed to perform in switching. So this is the lab that I'll be using, right? So, okay. And then apart from this, let me just open up the PPTs now, and then we'll proceed further with the training. In fact, before I proceed further, I know that all of you, like all 4 of you on this call, having working experience, right? But even though I don't know, like if you are really working on switches or you're working on firewalls or maybe on routers, I really don't know. Therefore, I would like you to take you through one more place here on cisco.com, let's say, right? So I will go back to cisco.com. You should be knowing that how to search for different switches which are provided by Cisco actually to their customers, or which are sold by Cisco to their customers. So we should know about that which different types of switches we have got there. Now remember, I'm not going to cover each and everything because even you would not have each and everything, every information listed here on their this website cisco.com. But yeah, there is a CCW right where you could try to order your switches, and that's where you would get more and more options. But over here, let me show you which all things you have got. So if you go to products and services, then go to networking, and then here you can click on view all networking products. There is an option called view all networking products, or you could directly click on switches. But let's click on view all networking products. Once you click there, then you would have so many different options, like you probably you're looking for devices for your access networking, for data center, for industrial IoT, for network security, network software. So like you can define your area, right? But then, since we are looking only for switches, right? So you can scroll up a little more, right? And then you could see that they have a dedicated option available for switching, right? So you could click explore switching. When you click on explore switching, you would get to know that there are like different switches available and provided by Cisco. You could see that here. So there are switches where there are fixed RJ45 ports available, like you could see those in images, but again depends upon that which series of switch you are working on. And nowadays there is one more thing that you should know about, that there's a Cisco DNA center that has been renamed by Cisco as Catalyst Center. So Cisco has renamed the Cisco DNA Center with the Catalyst Center. Even they have not updated that yet on their website, right? So website says DNA Center, but now it has been renamed by Cisco as a Catalyst Center. So usually we use this Catalyst Center for centralized management of your Catalyst switches. Remember, you can manage your Catalyst switches from this Catalyst Center. At some level, you can also manage your Nexus switches from this Catalyst Center. You can see, like, at least you can perform monitoring. But yeah, for Catalyst switches, you can do a lot of things. Like you can perform monitoring, you can perform configuration from centralized location or from the centralized management center, and also you could perform some sort of automation. There are so many things that you could do using Catalyst Center. I'm not moving into that because that's not part of this training, but yeah, I just wanted to let you know that nowadays it is not really mandatory to configure your switches individually through the console. The time has changed now, so it is not really mandatory for you to configure your switches by leveraging its console access, or logging on to switches remotely using telnet or ssh, whatever. It's not really necessary. So you can have a Cisco DNA center, also known as Catalyst Center, and you can utilize it to configure your switches. So you don't have to log in onto all switches individually. Anyways, Cisco switches for every network. So you know that since all of you are working, and I'm assuming that you already have gone through the CCNA training. And even if you have not gone through the CCNA training, then you should be aware, like, when it comes to the network architecture, generally you get two-tier architecture or three-tier architecture, right? So if you remember three-tier architecture, then you had access, distribution, and core. And in two-tier architecture also you had access and core. And that's what you have got here. So access layer switches, then core and distribution layer switches, then data center switches. So for data center, usually you would have Nexus switches, and that's what you have here. You have Nexus switches for data center. And during this training, I'm not going to talk about the Nexus switches, okay? Because all we are going to cover here is catalyst switching or catalyst switches. So from Cisco, you generally have two different types of switches that you can buy, you can purchase. One is called Nexus switches, which are mainly used in data centers or by the service providers. And even if you are a large customer, if you have got a large enterprise network, and you are deciding to replace your core switches, let's say earlier you had Catalyst one, now you can plan to replace them with the Nexus switches. But yeah, generally Nexus switches will be used in data centers and by the service providers. But yeah, for enterprise networks, like for branches, like headquarters or remote branches, you would usually go for Catalyst series of switches. So if you look at here, you have got like 9200 series of switches when it comes to Catalyst switches. Let me tell you one more thing, that earlier we used to have like Catalyst 3500, 3600, 3700, 3800, right? That has gone. 4500, 6500. So that time has gone now. And Cisco recently, so it's not that recent. I would not call it couple of months. It's been couple of years now, 3, 4 years. But yeah, Cisco is now focusing more on their Catalyst 9K series. So when I say 9K, under 9K, they have got 9200, they have got 9300, they have got 9400, they have got 9500, they have got 9600. Now in meantime, they also have the Meraki switches. And again, during this training, I'm not going to talk about the Meraki switches because we don't configure Meraki switching using CLI at all. Even there is no option for connecting the console cable for Meraki switches, although you can still have the management access of your Meraki switches, and you can configure them locally if required. But generally, Meraki switches are configured by the cloud-based controller. So Meraki has got a cloud-based controller to manage all their Meraki products. Now, again, Meraki was acquired by Cisco, so Meraki is part of Cisco. Anyways, in this training, we are not going to talk about this Meraki. Okay. Well, again, so what I was trying to say is, with the 9K series, you have got 9200 series of switches. You can use them as your access switches. You have got 9300, you have got 9400. Then for core and distribution, you have got 9400, you have got 9500, you have got 9600. You can also have the Cisco embedded series of switches. So when I say embedded series, so you could see that they have got Cisco Catalyst ESS 9300 embedded series switch. ESS stands for embedded series switch. Okay. So those are the high-end switches, and mainly used for manufacturing units or maybe you can say even for manufacturing units, they have got these industrial Ethernet switches like IE series, industrial Ethernet rugged series of switches. So embedded is mainly used by the defense, and then industrial Ethernet switches are mainly used by the manufacturing units where temperature might go higher or might go down as well, right, than usual. So that's where you would prefer to use industrial Ethernet switches or IE 9300. So when it comes to 9300, it's the normal 9300 here, like at least 9300. You could see that. Then you have got this ESS 9300, which is embedded series switch. And then you also have got IE 9300, which is industrial Ethernet switch. For small businesses, also you have got a small switches. Generally, you would go for Meraki in that case. But yeah, for Catalyst also, I mean, if you still want to use catalyst switches for small businesses, then you have got some compact series of switches like 9200 is there. So for small businesses, you can use 9200 series of switch. You also have 1300 series managed switches, and then you also have like unmanaged switches like 110 series switch. So Cisco is also manufacturing unmanaged switches like Cisco Business 110 series switch, right? So plug and play capability, and these are not manageable. These are just unmanageable switches. You cannot manage them. You can't have the console access of these switches. For management, you get either Meraki dashboard, which is a cloud-based management center, right? Or you can go for the Catalyst Center to manage your Catalyst switches. Using Meraki dashboard, you can manage your Meraki switches. Nowadays, Meraki, like Cisco has given you a flexibility to even add your Catalyst switches on your Meraki dashboard. So that is also possible. So cloud monitoring for Catalyst switching is now available. However, you cannot make any configuration on your Catalyst switches using Meraki dashboard or Meraki controller. Anyways, let's get back to the Catalyst Center. So it's like earlier it used to be called as a DNA Center, but now Cisco has renamed it. And the purpose of this Catalyst Center is to monitor all your switches from a centralized location. Not only monitoring, but also you can perform upgradation, you can perform troubleshooting, you can make configurations, and on top of that, the fabric can be created. A virtual networking can be created, and VXLAN will be utilized to create that fabric. But that can be done using Catalyst Center, and that's what SDA is all about, software defined access. And in this training, we are not going to touch SDA. You have got a separate training module for Cisco SDA, like we do for Cisco SD-WAN. So we have a dedicated module for Cisco SD-WAN and a dedicated module for Cisco SDA. In this training, for learning switching with me, we are not going to talk about the Catalyst Center. So mainly, I'll be using like normal iOS and also iOS XE. Now, one more thing that I would like to bring up here, like the topology that I showed you here, these switches are using normal iOS. If you look at here, so it's using iOS 15.2. Nowadays, none of these switches, like if you particularly talk about 9K series, so whether it's 9200, 9300, 9400, 9500, and 9600, any of these Catalyst series of switches do not use normal iOS. They all are using iOS XE. And in fact, you would see or you would observe that Cisco has stopped giving you normal iOS images for any of their routers or switches. Earlier, we used to have like normal iOS images for Cisco routers and switches, but now you would observe that Cisco is releasing or Cisco is providing their router switches with Cisco iOS XE. So they have got an operating system called iOS, just iOS, a plain iOS, and also they have got another operating system called iOS XE. So now in most cases, everywhere you would see iOS XE, whether it's their routers, it's their switches, or it is their WLC, wireless LAN controller, or even it's their AP, access point. Like earlier, we used to have a different operating system for AP, different operating system for WLC. But now, everywhere, Cisco is utilizing iOS XE. So it becomes really easier. Like if you are comfortable with the command syntax of iOS XE, then it is easy for you to manage the access point or WLC or switch or a router because command syntax is same. Why? Because they all are using same operating system. So nowadays we are using iOS XE. Now, if you look at the iOS XE, because this is all we are talking about a platform or a hardware device. Okay, so let's talk about 9300 a little, and also I will talk about 9600 or maybe 9500. Okay, So let's talk about 9300 first. When it comes to 9300, you would get to know that there are many models. There are many, and all models are not listed here on this website. If you go to CCW website, I mean, if you have access to their sales portal, then you would get to know that they have so many models when it comes to the 9300. But yeah, some of them are here, like 9300X copper model. So do you understand the meaning of X copper model here? Which means that they have got the copper ports available. Do you get it? Do you get the meaning of copper model here? That they have got RJ45 ports available, the copper ports available on this switch. The fiber model will have only fiber optic ports. You will have to install the fiber SFPs, and then only fiber ports can be found on this series of switch. And then high performance model, either you can go for 48 port or you can go for 24 port. So it's up to you. Then you have got PoE models, 90 watt and then 60 watt PoE model. So when I say PoE stands for power over Ethernet. So if you want your switch to provide power along with network connectivity, then yes, you will have to go for the PoE switches, power over Ethernet switches. You have 1 gig model as well, where you would have like 1 gig copper ports for data only. Those are not PoE ports. 9300L model is also there, 2448 port, like this series of switch is there. You can go for either 24 ports or 48 ports. And some of them are also supporting like PoE as well, like this specific platform will support PoE. This is specific platform will also support the PoE. So it depends upon your requirement, and then only you are going to pick your platform. So this is how the 9300 series of switch will look like. So now look at this. So this switch has got only RJ45 ports available here. You could see that. Okay.
Is it a redundant power? Does it have?
Yeah, absolutely. You will see that now.
Right.
Let me show you. There you go. Come on. These are fans, and then see here. So I've got redundant power supply installed here.
Okay. And these are stackable too, I think.
Yeah, absolutely. And without
Right.
stacking, nobody goes. I mean, nowadays customers are really focused over stacking because that really helps them to reduce the administrative efforts. So customers are really focused over the stacking feature because in most cases they are using this now. So Cisco IOSXC cloud native. So what is the meaning of cloud native? Which means that you can also manage them using Meraki dashboard or Meraki cloud. You can monitor them from there. Okay.
So the iOS XZ, what does it mean? Like, when we have iOS simple and iOS XZ, when they put like
Um,
XZ, that is something
Yeah,
different.
so command syntax is also quite similar, but yeah, this has been there in Cisco for a long time now. So now Cisco is also focusing over having a kind of like common operating system for most of their devices, and they are more focusing over Cisco IOSXC. So here on these all 9K series of switches, you're gonna find only IOSXC. Now the command syntax for normal iOS, the plain iOS and IOSXC is same. I would say that there are some additional features supported by IOSXC, not by iOS. So if you talk about like doing packet captures, those command syntaxes were not supported by the normal iOS as long as I can recall. Right? I may be wrong, but the packet capture command was not supported by normal iOS, but IOSXC does. So there are some features which have been added into IOSXC or which are supported by iOSXC, but not by the iOS. And in fact, let me also tell you one more thing. If you are thinking to have normal plain iOS on your 9K series of switches, that's not possible. Why? Cisco never built normal iOS for their 9K series of switches. And in fact, we can identify that. So if you go to his website called software.cisco.com, you go there, then click access downloads, and then if you go to download section for like now say okay 9300 series of switches, look at there because I got that shortcut created, maybe I must have downloaded that. So now it depends like which switch you have got there. So see how many platforms you have got here under 9300 series. So for an example, if you have got 24T or maybe 24T E switch, let's assume that. Now look at the operating system, IOSXC software. So they don't have any option for normal plain iOS. All they have got for you is IOSXC. And as I told you, nowadays, whether you are buying a router or a switch from Cisco, you are always getting IOSXC. There is no plain iOS anymore. Yeah, if you have the older switch. So for an example, if I go back here for access switches, and then if you look at, let's say, the 3750 series of switches, then iOS software is there. It's not IOSXC. It's normal iOS. Do you see that now, guys?
So there on iOS XZ there is some features which is added, but it doesn't
Exactly.
have it when. on this one. Okay.
Yep. So these are the old switches. So Cisco is still keeping the iOS images for their old devices, like old switches, old routers, right? Where they had only iOS images, not iOS XE. So you can still get them downloaded. So the most latest version for this series of switch is, you could see here, 15.2. Yep. That's the most latest iOS image that you have got for this series of switch. In fact, we can expand this. Yep, that's the only thing we have got here. If I go back and if I select like 9300 or 9200, so those are the latest series of switches, right? Like 9200, 9300, 9400. So even if you go for 9200, 9224p switch, you would get to know that they have got an option only for iOS XE. Now, I would show you one more thing here. I would like to mention it now. Somewhere you would get this iOS XE software only. Like on this 9200, on this 9200 series of switch, I've got an option only for iOS XE software. I can download that and I can install it. So for iOS XE, I've got 17.16. Yeah, that's probably, let me expand this. Yeah, 17.16 is the most latest version that we have as of today while speaking with. That's the most recent image that we have got for 9200 series of switches. In fact, it should be same for all, whether it's 9200, 9300, 9400, 9500, 9600, even for routers. The iOS XE, the most latest version should be 17.16 only. All right, I'll go back now. If I select 9300 now, let's say 9300 and then 9300 24SE switch. Here, you would have two different iOS XE images, like iOS XE software, and then you also have got iOS XE WLC software package. Do you see that? This software package? What does this mean? Which means that this switch 9324SE comes with a feature called embedded WLC. The switch comes with a feature called embedded WLC. Now, what is the meaning of embedded WLC? The meaning of embedded WLC is that you don't have to buy, you don't have to purchase a separate WLC. On switch itself, you have got WLC. So your switch is not only working as a Ethernet switch, but also it will work as a WLC. And you can have the GUI access of your WLC. Like you just have to allocate an IP address on your switch, then have the GUI access of it, and then access your WLC. And then you can register your APs to that WLC. So you don't have to purchase a separate WLC anymore. The Cisco has added a feature called embedded WLC on their 9300 series of switches. So it depends. Like on some platforms, it will be there. On some platforms, Cisco is giving you a feature called embedded WLC. On some switches, it will not. Like we saw that on 9200 series of switches, we never had this option. But yes, on this 9324 SE switch, we have got this feature.
So is this available on all 9300 switches? SE?
No, not on all. I believe so. That's my understanding. It's not available on all. Although I haven't gone through all the platforms, but yeah, I mean, if you
Mm.
go back here, let's say 9300 24HA, let me see. So yeah, it's there. So you will have to see that. Basically, I'm not really sure if they are giving it
Mm.
for all their platforms within this series, but yeah, we will have to check on that.
Okay, the one that have that option, like to
Yes,
download the iOS 60 for
exactly.
wireless. Okay.
Yep. Like 9300L is also there, right? So you could see that, yeah, WLC is still, I mean, is also there, right? Good. So fine. I hope that you got an idea now that we're gonna work over iOS XE only, not on plain iOS anymore. In production, you would see devices, you might find your devices still running on normal. That's about iOS XE. However, as I mentioned that in my topology, I have got switches running on normal iOS, but I also have switches running on iOS XE. So going forward, like I'll have to replace these switches with those switches having iOS XE images, right? So I'll be running those switches. Don't worry. But thing is that in most cases, like especially the topics that are listed on Cisco's website, all those topics can be done on a switch running on normal plain iOS or maybe running over iOS XE. And even the command syntax is also same. Now there is a question that Mohammad Shakil has asked in chat. Mohammad Shakil, I'm sorry to look at your question late because usually I don't read chat, but since today your audio is not really connected, so I just tried, I just opened it up. So you says that what is stackable? What is stackable switches? So the meaning of stackable is that if you could, if you could convert your multiple physical switch into a single virtual switch, that's called stacking. So if your switch has got a stacking feature, then we call it stackable. So like if you have got four switches, now generally if you have to configure four switches, then you have to take the console access of all four switches, and then you will have to make the configuration changes. But then if you have created a single stack of all four switches, then you just have to log in on one device and then do whatever you want to do. Let's say you wanted to create VLANs, you wanted to put or you wanted to provide some VLAN membership, do it just on one switch. Or if you are enabling some other things like configuring NTP servers, syslog server, just do it on one switch, and then it will be applicable for all. So that's the benefit that you get by configuring stacking, or by putting your multiple switches into a single stack, right? So management becomes really easy when you have converted your multiple physical switches into a single logical switch by leveraging stack cable. So we usually have the stack cables to put your switches into a single stack, and I'll explain you that later, that how we create a stack. Okay, because that's really important for us to understand that how to create a stack, and not only that how to create a stack, but also how to upgrade devices, how to upgrade switches just in case if they are in a single stack. That is also important. Any questions for now? All right. So I hope that everybody got an idea that when it comes to the latest series of Cisco switches, the Catalyst switches, then it's 9K, 9000 series. And under 9000 series, we have got 9200, 93, 94, 95, 96. And now if you look at the 9600 series of switch, look at this. This is giant switch. Look at this. It is a chassis. Are you able to see it? Like if I stop it right there, it has got two supervisor engine here, like SOUP 1 and then SOUP 2. Those are the main CPUs of this switch. And then you have got two line cards, line card 1 at top, line card number 2, and then line card number 3 at number 5. Right, because slot number, like if you look at this slot number 3 and 4, those two slots are reserved for the supervisor engine. And then you have got line cards available on slot number 1, 2, and then 5 and 6. Those are the slots available for your line cards. So this is how this switch will look like. So it's a very, very big switch. So it's a modular chassis. In total, it has got 6 modules. First two modules are reserved for line cards. The next two modules are reserved for supervisor engine. And last two modules are again reserved for line cards. It has got multiple power supplies here. You could see 1, 2, 3, 4 power supplies. And then it has got many, like two supervisor engine, right? You could see that. And then we have got line cards. Yeah, and line cards can also support like 100 gig. So those ports are also available on this switch that can support like 100 gig of bandwidth. And this is how it will look like. So you can open it up. These all are the fans for your switch, right? So how many fans are there? Like in total, 9 fans you could see right in front of you. Right, so this is how it looks like. Again, you should know that which all supervisor engine you have got. So you have got like this Gen 2 supervisor engine and then Gen 1 supervisor engine that you could look at here, right? So you should know that what are the line cards, what are the, chassis, and then what are the supervisor engines. So you have got chassis, where usually you get 6 slots. And the good news is that currently you get only one type of chassis. Like earlier for 4500 and 6500, you had so many different types of chassis. So many different types of chassis, like 4503, a chassis which had 3 modules or 3 slots available. 4507, which had 7 modules. And 4510 or 6503, 6506, 6507, 6510, 6513. So you had different chassis. But good news is here that in 9600, you have got only one type of chassis, which is C Catalyst 9606R. So this 06 indicates that there are 6 modules that can be installed. There are 6 trays, I would say. And then supervisor engine, there are 2 different types of supervisor engine. One supervisor engine will support the throughput of 66.4 terabits per second, whereas the other supervisor engine is also there, which can support like 2.4 terabits per second type of throughput. So any of these supervisor engine will require to be installed here, and both supervisor engine must be same. You can't do like one of the supervisor engine is this 9600X soup 2, the other supervisor engine is soup 1, right? You can't do that. Either you have to opt soup 1 or soup 2. So both supervisor engine must be same. And then when it comes to the line cards, so you have got X fiber line cards that can support like up to 400 gig, 200 gig, 100 gig fibers. And then you have got another line card that you could also install where you can have the copper ports like RJ45 ports with this line card. And if you are going for this line card, then it can support like up to 100 gig and 40 gig as well. So there are many different types of line cards available. So this line card will have different capacity and capability and different types of ports. And even you can have like a line card that would have 48 SFP fiber ports available. So it's up to you like which port you're looking for. And then 48 10 gig multi, 10G multi gigabit copper. So that's the line card for that purpose. Okay. So the line card you will have to choose based on your requirement. So obviously you can have different line cards. It's not mandatory for you to have, because see, in total you can have 4 line cards. Now it is not really necessary for you to have the same type of line cards. No, let's say one line card is 9600X series, the others are 9600 line normal 9600, not X. So some of them can be like 9600 LC 24C, and some of them can be LC 48TX or 48S. 48S is all about fiber, whereas 48TX is all about the copper RJ45 interfaces. Okay, so you should
we
read
can
about it. Yeah,
we can make a custom custom line
like
cards,
like okay, when you say custom line cards, what does
like
this mean?
let's say I want like fiber line cards, 24 port 100 gig and 48 port 10 gig. Just an example. So we can choose, yes, different line cards.
I mean, you can have any of these line cards. You can have custom line cards. So when you say custom, you cannot ask Cisco to manufacture the line cards based on your requirement only.
Okay. Oh,
Yeah.
okay. Yeah.
Yeah.
All right. That's what I want. Like, just like a computer, we are selecting. Okay, we need a processor, all those kind of stuff. I thought we can do a customizations on the line cards on these ones. It is what it's available on their website. You can choose from there.
So you can pick and choose from the available options. Okay, cool. Anyways, I hope that all of you are now good. And this is the only switch or only series where you have got this chassis. If we talk about like 9500, for 9500, you don't have any chassis. So it's not a chassis, it's an appliance. Look at here. So you have got 9500X model or you have got 9500 high performance models. But those are appliances, not chassis. So if you want to have a chassis, if you want to buy a chassis, then you have to go for 9600. That's the only option you have got available. But if you talk about 9500 or 9400 or 9300, 9200, you can't have chassis. For all these series, we have got only appliances. This is how
Yes.
this switch will look like. So it's easier for you to, to look at the switches, different types of switches. So this is how it will look like. So you will have to install the SFPs. That's the only option you have got here. So you have got type C console port, which is fine. And then you have got port options like SFPs you will have to install. So 400 gig quad SFP. And then, so that's how it looks like. So while buying the SFPs, what you could do is look at the data sheet, and then you could easily get to know that which all SFPs you can have on these switches. This is how this switch will look like. Obviously, the different models can look different. Like this is switch 1 at top, then switch 2 in middle, then switch 3. All are looking a little different from each other, right? So 9500X models, then you have got normal 9500 models. All are running with Cisco IOS XE that can support plug and play, automated device provisioning, API driven configuration, like using API, you can make the configuration. Cloud monitoring, which means that you can integrate this with Meraki Cloud. And also you can have the GUI access of your switch. Even you can make the configuration. And if you get down here, you would also get to know that which all different types of SFPs are supported here, right? So this is your, come on, so 9500 series of switches. So you can see all these switches are 9500 series of switches with different I would say different features, but let's not say different feature. I would call it like having different number of interfaces. And then you will have to look at the number of the ports available for each series of switch. The port density, it's different, obviously. If you keep going down, the SFPs, these are the network modules that you can install if available. And on most switches, it is available. Then accessories. So you have got rack mount. You also should have an option to look at the SFPs, like which all SFPs are supported here and all that. Come on, these are the power supply specification. No, I don't want to look at there, but you can read it, right? So these are the white papers, and then you can also look at the more information like switching capacity, forwarding rate, total number of MAC addresses they can have in their MAC address table, the number of routes they can have in their routing table, multicast routes, and then direct connected routes or indirectly connected routes, and all that information is given. Number of ACL entries, the number, the amount of DRAM they have got, the amount of flash they have got, number of VLANs that they support, number of PVST instances that you can create. You can look at all this information. Total number of SVIs that you can have on each switch, the jumbo frame is supported or not. That's that. The number of obviously multicast security, ACL, QoS, ACL, Lisp, span. So Lisp is supported there, right? Lisp routes are supported there. Control plane policy. So all the information is given. What's supported, what's not supported, and even they should have an option to tell you that which operating system you require on which model. The minimum software required. So look at the minimum one. Smart licensing. So you have got like DNA subscription, advantage, essential. So you can opt any one of them. And I was looking for SFPs actually. Yeah, optic transceivers modules, right? So here you could look at this information. So for the latest Cisco optics transceiver modules compatibility, go there, and then you can look for that information. So this is what I wanted to show you. So you can go to this portal, and then you can look for the compatibility matrix that which SFPs should be installed on your switches. Okay, I hope this is well enough from the basic stuff of switching. The next thing that we're gonna go ahead and continue with is hold on. Now from tomorrow, I'm gonna follow the PPTs, right? And let me show you that what all things we are going to cover again. So we're gonna start with fundamentals, and then we're gonna go ahead and talk about these different series of switches, then switch port, CDP, LLDP, designing. Then we're gonna talk about switch operations like MAC address learning, filter and forwarding decision, what is unicast, multicast, loop avoidance, right? And then how the architecture works for layer 2 switches, for layer 3 switches, what is SEF, what is adjacency, what is fib, right? Packet rewriting. So that's what you're going to learn. Like this is an architecture that is followed by the layer 3 switches. VLAN trunking. Then after we have to cover VTP and DTP. VTP is not there in this PPT, but I'll be covering that briefly, right? Although we never saw VTP part of the Cisco's content as well, right? They have removed VTP, but I see that few customers are still using VTP, although it should not be used. But yes, still I would like to explain you the VTP along with DTP, then interval and routing, and then spanning tree protocols. Once you do spanning tree protocol, then like obviously you have got three protocols to cover: PVST plus, rapid PVST plus, and then MSTP. So these all three protocols will have to be covered during this chapter. And then you have got ether channel. Then you have got after ether channel you have got the STP protection, and after STP protection you have got some security features like DSCP snooping. Then you have got um, you know dynamic ARP inspection. Then you have got IP source guard. Then you have got port security, storm control, then VLAN access list, private VLANs. Right. So these all are the topics that we are going to cover, right? So then finally high availability using HSRP, VRRP. So that's what you're gonna cover, and also the stack wise, like how we configure the stacking, how does it work, and all that. What is VSS? Because to configure multi-chassis ether channel, which is also known as MEC, we need kind of VSS. Or nowadays, if you are using Nexus switches, then you configure VPC there. Then you got to know that what is the meaning of having redundant supervisor engine, HSRP, VRRP, and then that's it. That's all about switching. That's all you are going to cover throughout this training. So that's what we have to cover. So tomorrow I'm gonna go ahead and start with the normal, although I have already discussed with you, this is stuff like how we could categorize the switches like at access layer, then distribution, then the core, and then we have already seen that per Cisco, like if you even visit the Cisco's website, it is pretty much clear that for access layer, we should use any of these series of switches. For core and distribution, we could use any of these two series of switches. That's something that we have already discussed, but yeah, we'll just go through the switching fundamentals quickly. And one more thing, guys, that in this switching, we're going to focus only on catalyst switches. We are not going to cover anything over Nexus switches. And also we are not going to cover anything over Meraki switches. And also we are not going to cover anything over frame relay switches or ATM switches. It's all about catalyst switches, Ethernet switching. That's all we are going to cover over here. So like earlier, we used to have 33650, 3850, 3500, right? And then we had 3750 as well. Then 4K series 4500, 6K series 6500, 6800, and then you have got the WLC. But that embedded WLC is also available for 9K series of switches. Like we saw that for 9300. Like 9300 comes with a feature called embedded WLC. Here you could look at the switch, like how many slots are there? Can you see that how many modules are installed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it seems that it is a 6510 series of switch. There are 10 modules installed here. So which means that there are 10 slots. So it seems to me either it is 4510 or 6510. I cannot really read anything specific to this switch, but it seems to me that it is either 4510 or 6510, because for Catalyst 9600 we don't have 9610, so it cannot be a latest 9K series. It is an older switch. So just imagine that how much ports or switch ports it has got here, right? So like each line card is having 48 ports, so you can simply say 48 multiplied by 8, in fact 7, I'm sorry, yeah, because no, I would say 8. However, this line card here, the line card number 5 here, underneath supervisor engine 2, this line card is having only slots available where you can insert SFPs. So this whole line card is mainly for fiber optic cables or fiber connections, right? You could see that here. But other than that, you can simply multiply 7 by 48. Then you can simply count that how many number of interfaces are available on this single switch. So it's a single switch. So that's what we are going to cover tomorrow, like types of ports on your Catalyst switches. I'm not talking about Nexus switches because Nexus switches has got so many other things as well. And there are so many different things on Nexus switches. So once you start working on Catalyst switches, do not assume that you have also got the expertise around Nexus switching. No, you still have to go through that training, that which all features are supported by Nexus switches and how to make the configuration, because the configuration on Nexus switches is little different than what we do on Catalyst switches. Okay. Anyways, I think this is it for today, kind of introduction. Right. And tomorrow I'm going to start with the types of ports available on your Catalyst switches, like what is switch port, how does it work, how to get it disabled, how to get it enabled, and all that. Right. And then layer 2 port, layer 3 port, and then we'll talk about the VLANs, how to create VLAN, the standard range of VLAN, extended range of VLAN, then internal uses of the VLANs, then voice VLAN, normal VLAN, data VLAN, I mean to say, and then CDP, LLDP. That's all we are going to cover tomorrow. So I'm going to start from here, the types of ports on Catalyst switches. Here you go. This is how those SFPs will look like. I hope you got it. So some SFPs are for RJ45. So here I could see that this one, it seems, yeah, this is for RJ45. You look at there. So this is RJ45 SFP because you could install or you could connect your copper wire or RJ45 connector. So it's a SFP that contains the RJ45 port on it. Now, if you look at here, this one, so this SFP has to be installed on the slots available on your switches, and then you would be able to connect your fiber optic cable. I hope that you can clearly see that now.
Yeah, I
Hello?
see it, but I really have no idea. This is the first time I heard this term, so no idea what that is. Like, I mean, to begin with,
Okay,
just like a
so
basic definition.
yeah, I mean, see, I can't really give you more than that. Why? Because you're not physically present, else I would have displayed you, hey, this is, keep it in your hand. And because switches are not coming up with any ports, right? There are slots available where you can insert these SFPs.
Okay.
So switches are
Oh.
blank. Like if you look at this image here,
Mm-hmm.
this image. So switches are like blank, totally blank here. They have given
Okay.
us some modules there, but no
Mm-hmm.
SFPs are installed. So I cannot connect any of the cable on this switch. So what I have to do is I have to buy these SFPs from Cisco in addition to this switch,
Okay.
right? And we
Okay.
will have to insert this SFP on any of these slots, and then we can make the cable connections.
Okay.
And
All right.
the
So.
type of SFP will be depending upon that which type of connection you want to make. Like if you want to use the fiber optic like this, right?
Mm-hmm.
Then you have to buy this type of SFP which has the fiber optic connector.
Okay.
See, so it is supporting fiber optic connector over here. So this is the type of SFP that you would require to install on the given slot. But then if you require RJ45 connector, right, then you have to have another type of SFP which would have
Okay.
RJ45 connector available on it. Like for an
Okay.
example, if I go up here, so this SFP particularly is having this RJ45 port available. So we can also make the wire connection. I hope now things are pretty much clearer for you.
Okay. Yeah, that's good.
Yeah. Okay. Good.
And what's this box sitting on top of the switch?
Ah, that's a good question. So generally, it's your, like in racks, in physical racks, you have your, you don't want like direct cables coming from the other floors directly connected on your switches, right?
Oh. Okay. Okay.
So generally, in between, you would have this sort of like what we call it. I'm just missing that keyword. Any of you can chime in, Ashish, Jordan, if you would like. So you can also chime in, and it's known as generally your. Come on. I mean, generally, what we do is that if cable connections are coming from the other floors, those cables will be terminated here on this type of box, and then from
Oh, okay.
there
Oh,
you would take connect cable connection to your switches, and that way, you are eliminating the possibility of a cable becoming little shorter. For an example, if cable became faulty and then you are cutting the cable and making it again, or you are slicing the connectors again and you're making the connectors again, so at
okay.
one point of time the cable might become shorter, right? So we don't do that. We make the cable connections to this type of device first, coming from different floors, and then from there you would take your connection to your switches, and there is a
Okay.
specific
I get it.
terminology for it. I don't have that on
Patch
the top
patch
of my head.
panel. Patch
Patch
panel.
panel, exactly.
Oh,
Patch
okay. All right.
panel. Right. So
All right. Thank you.
this is patch panel. Okay.
Oh,
All right, guys. So let's get it started then now, right? And remember, as long as for network engineers like us, for me, for you guys, as important, these topics are like learning STP, RSTP. I would also encourage all of you to have some knowledge around the hardware stuff as well, like patch pen. What are the patch panel? How many different types of cables we have? We have got. How do we perform racking and stacking also? Because sometimes, we are going to the customer location as a field engineer, and let's say I am working for any of the organization. An organization has shipped a device to the customer location. Now customer is also looking for some help in terms of field engineer, because they don't know that how to rack and stack. So then you should be good with cabling, you should be with racking and stacking of the devices, like how to rack and stack a device. And then and I would encourage you to watch some YouTube videos. There are some people who have added or who have uploaded their videos onto YouTube, and then probably you can get better idea that how to perform racking and stacking of the devices. If somebody is already doing or has already performed that in past, fantastic, that's great. But if not, then I would really recommend you to go through the YouTube video to see that how we really perform the racking and stacking. Because see, you would have a blank rack, not blank. Sometimes what happens, you have very uh, congested space within the rack, right? So you might have to adjust your devices, and so you have to adjust your cabling as well. I mean, you can't open your cables, you can't keep your cables in open, right? So the cabling should be proper. And trust me, not many people understand that, not many people does that, and not many people are really familiar with racking, stacking, and doing cabling and all that stuff. I'll just encourage you to get through it once, right? Get an idea that how do we do that, and that's it. Because you're not going to do that every day. That happens like once in a while, or maybe you're building up something from scratch, very scratch, right? That then yes, you would also be doing the racking and stacking. Anyways, let's get started from where we left yesterday. So just give me a sec, please. I hope that everybody is able to see the PPTs, right? So introduction to switching. So obviously, we should be knowing that what switching is all about. You know. So if you look at here, forwarding of frames based on layer 2 information is called layer 2 switching, right? Layer 2 switching. But if you are forwarding your data like IP packets based on layer 3 information, that's called layer 3 switching. And that is why we have got like layer 2 switches as well as we have got layer 3 switches as well, right? So if you have a device, you have a switch that can forward the frames based on layer 2 information, then you're going to call them layer 2 devices, and basically you're going to call them layer 2 switches. Nowadays, layer 2 switches are not that are not that really, I would say, not really famous nowadays, right? Although Cisco is still selling layer 2 devices, right? You can still buy layer 2 switches from Cisco, which is fine. But even if you look at the Cisco validated design guides, CVDs, right? If you look at the Cisco's validated design guides, they are not recommending us to go for the layer 2 switches anymore, right? So they are recommending us to directly go for the layer 3 switches. And layer 3 switches are those switches which can not only forward based on layer 2 information, but also they can forward data based on layer 3 information, which means that not only these switches will be forming MAC address table, but also these switches will be responsible to form routing table. So on layer 3 switches, you would have the MAC address table. You would also have a routing table. So in nutshell, these switches can forward your data, can switch your data based on layer 2 information. And also these devices, these switches can forward traffic based on layer 3 information. So when I say layer 3 information or layer 3 address, which is going to be an IPv4 address or IPv6 address. When I say based on layer 2 information, which is MAC address, right? So if your switches can switch your data based on MAC addresses, right, you're gonna call them layer 2 switching. And if your switch is switching your data based on layer 3 address, which means IPv4 or IPv6, then you call it layer 3 switch. So layer 2 switches are just layer 2 switches. They can forward frames based on layer 2 information only, whereas layer 3 switches would have capability to forward your data based on layer 2 and layer 3 as well, right? Now, sometimes we talk about the multi-layer switches as well. Like there is a terminology called multi-layer switch. Generally, am I audible to you all?
Yes, sir.
Okay, good.
Yes.
So if you talk about the multi-layer switches, those are high-end switches, right? Obviously, I mean, multi-layer switches or MLS has got the capability of forwarding your data based on layer 2 information as well as based on layer 3 information. But it can also use the port numbers to forward your data for the purpose of packet forwarding. And generally that happens when you are doing NATing. The high-end switches like 4500, 6500 series of switches, those switches can also support NAT, network address translation, which means that we can say that data can be forwarded based on the port numbers. Because when you do the netting, you build a translation table, and translation table entries are created based on the port numbers, right? So that's the reason that we are saying that it can include port numbers as well in packet forwarding. So that's MLS, multi-layer switch, but that's okay. I mean, in production environment, you would not see too many switches supporting NAT, or you would not see too many switches as MLS. Right. Generally, you would see layer 3 switches nowadays. And even Cisco is recommending everyone to go for the layer 3 switches rather going for layer 2 switches. Although Cisco is still selling layer 2 switches. So if you want to buy layer 2 switches, you can still buy them, but not recommended by Cisco. Modern day campus area network is all about Catalyst 9K series.
So that was launched by Cisco, as I even mentioned. I brought this topic yesterday as well. That a couple of years back, Cisco launched this new, whole new Catalyst 9K series of switches, and that's what they are recommending us to use nowadays, right? So Cisco is recommending us to use this whole new Catalyst 9K series of switches, and I told you that we have got like 9200, right? Then we have got 9300, we have got 9400, we also have got 9500, and then 9600 series of switches, right? So this is 9K series. And then earlier we used to have 3K, those were layer 3 switches, right? So earlier we used to have what? 3K series of switches like 3500, right? 3550 or 3560. Then I would say 3650, right? 3750, 3850, 3760, or 3860, kind of that, right? So that's called 3K series, right? So earlier we used to have 3K series, and that was also layer 3. That was also an example of the layer 3 switches. Nowadays we don't use layer 3, I mean 3K series of switches, right? We don't use them. And if any customer is already having 3K series of switches, they're getting them replaced by this Catalyst 9K series of switches. So that's what they are doing now. 6K series of switches were also there, like 6500 series, giant switch, chassis based switch. It's a chassis basically. And you could see 6503, 6505, 6507, 6510, 6513, and so and so. So you have got 6503, 6505. So the meaning of 03 or 0507 is the number of slots that chassis would have. So if it is 6503, which means this chassis can have maximum 3 modules installed on it. 6505 would have a space only for 5 modules to be installed, and 6507 would have a space only for 7 modules, and 6510 would have the space for 10 modules, and same goes with 6513, which means it would have 13. It would have the space available for 13 modules to be installed. So that's the meaning of that. And you also had 4K series, like 4500, right? Then one of the major advantages of these switches is the ability to be managed by the controller, which is called DNAG, right? So that's the best part of Catalyst 9K series of switches, that we can manage them using a centralized controller, right? Which is now, which is called, or which is known as DNA Center. However, Cisco has renamed it now, and they are calling it Catalyst Center now. They are calling it what? Catalyst Center. So we can manage all these switches, not only just 9K, but you can also add your 3K series of switches, right, onto your DNA Center, and you can manage them from that controller, centralized controller. However, you will have to see that which all switches are supported in Fabric. Like if you are looking to create a Fabric, right, because using DNA Center, we can also create SDA Fabric. So if you're looking to create SDA Fabric, then I would really recommend you all to see that if your 3K series of switches are supporting the SDA Fabric, the 3K series. So I know that 3800 supports the SDA Fabric, but others like 3550, 3560, 3750, they do not support the Fabric creation. However, you can still add them onto DNA Center, which means Catalyst Center. You can get them upgraded. That is absolutely fine. No problem with that, right? Most of the switches that we use nowadays are routing capable. As I told you that nowadays we are using layer 3 switches only. We don't use layer 2 switches anymore. And there is a benefit. There is an advantage of doing so. So if your all switches are routing capable, then you can create a fabric, like you can create VX lane, right? You can implement VX lane. Obviously, I'm not going to teach you VX lane as part of this switching. However, in SDA, software defined access, because you will also go through that training. And during your SDA training, you would get to know that what is VX lane. So if you implement VX lane, then you don't require STP, spanning tree protocols, running in between switches. You don't require any trunking in between switches. All you need to have just layer 3 interfaces between your switches, and then rely on your routing. So that's that. The next is, like, if you look at the campus area network, the switches that can be used in a campus area network. So Obviously, as I told you, that we have got a brand new 9K series of switches, and that's what we should be using: 9200, 9300, 94, 95, 9600 series of switches. But then, as I told you, in early days, we used to have 3K series of switches like 3650, 3850. So those switches are still available. I'll have to double check on it that if Cisco has made them as end of sale. If Cisco has declared them as end of sale, then we can't buy them. But I'll have to get it confirmed. Then Catalyst 4K series like 4500 series, like 4503, 4507, 4510, like that. And then 6K series like 6500. And again, within 6500, you would have 6503, 6505, 6507, 6510, 6513, and all that. So we have already discussed about this stuff, right? So sometimes you would have a switch, which is a kind of appliance like this. So this is an appliance. This is one switch, and this is another switch. So these are two switches. So it's up to you whether you want to buy a switch having 24 interfaces on it. So like you could look at here, the switch is containing only 24 interfaces, or you could buy a switch which has like 48 interfaces over there, right? So it's up to you that how many interfaces you require on a switch. And also there is a difference of having uplink ports. How many uplinks are available on this switch here? 8. 1, 2, 3, 4, 5, 6, 7, 8. But those are the slots available. You will have to insert the SFPs again. So Shakil, so you could see that the other ports are RJ45 ports, right? And we can insert the RJ45 connector on it. So we can make the cable connections. But here, if you look at the uplink ports, these are blank slots. So we can insert SFPs there. And again, it is up to you whether you want to use the copper SFPs, like a SFP containing the RJ45 port on it, or a SFP which is containing the fiber optic ports over here. So this is what it is. Any questions so far? No? Then the other switch, it has got like two SFPs, two slots for SFP to be installed. So yes, and you can change that basically. You can open this up like the entire slot, and then you can insert some other slot if needed. So it's up to you, like which slot you are using there. So fine. So these are appliances, and this is chassis. This is how the chassis looks like. Even yesterday we went through that, right? Now let's talk about types of ports available on your switches, on your Catalyst switches. So generally you would have a switch port. By default, all ports of your Catalyst switches, I'm talking about all Catalyst switches, whether you are working on 9K series of switches, like you have got 9200 series of switches, or 9300, 9600. So types of ports on a Catalyst switch. As I told you, by default, across all Catalyst switches, by default, their ports are switch ports. So when I say switch port, which means that those are layer 2 ports. Even on layer 3 switches. So if you are buying a layer 3 switch, let's say 9200 or 9300, still their ports will remain are by default as a switch port, right? Those are configured as a switch port. So switch port is that port. Switch port is a layer 2 port basically. And if you disable switch port, because there is a command that we can run, no switch port, then it can become a layer 3 port. Now, if your port is a layer 3 port, then you can assign an IP address on it. If it is a layer 3 port, then you can assign an IP address on that port. And if switch port is enabled, which means that it is a layer 2 port, then it must be a member of a VLAN, or it must be a trunk port. So if your port is a layer 2 port, which means it is a switch port, and then it must be either member of a access VLAN, or it should be configured a trunk port. So these are the only two states. Like either your switch port would work as an access port, or it will work as a trunk port, or maybe it will be a down. Like it will be in down state. Let's say there is no cable connected on a port, then obviously it cannot be either access port or maybe a trunk port. But yeah, by default, all switches would have the switch ports, which means that no matter which type of switches you are working on, by default, their ports are switch ports, which means by default, their ports are layer 2 ports. Layer 2 ports can be changed as a layer 3 port, but again, it will be depending upon like which platform you are working on. So if it is a layer 3 switch, yes, you can change your port from layer 2 to layer 3 by using this command. But if you have a layer 2 switch, like for an example, for layer 2 switches, you can rely on, like earlier we used to have 2900 series of switches, like 2950, 2960 series of switches. Those are layer 2 switches. And if you go to those switches, and if you go to interface mode, and then if you try to run this command, no switch port, it will not be accepted by these switches. Why? Because those switches are layer 2 switches. So none of their interfaces can be configured as layer 3 interface. Okay. And one more thing, if you have converted your port from layer 2 to layer 3, but now you want to set it back as layer 2, then again you can run this command switch port under interface mode only. Now these commands are not applicable for layer 2 switches, because on layer 2 switches the ports can be layer 2 only. Ports will always remain as switch port, so you can't convert them from layer 2 to layer 3. Now obviously let me have the access to the switches, and then we can talk about more about it. We can talk more about it. So just give me a sec. Let me have lab access. And how about you guys? Do you guys already have labs created on your local machines, or how are you going to access the labs? Or would you have access to the I-MEDITA labs?
I don't have any access yet, so that would be my question, though. And then, how do we access to the labs? I don't have anything set up already.
Okay. Who is your account manager here in India? I got I-MEDITA.
Pooja.
Ja. Okay. Can you ping her today?
Yeah, sure.
Yeah, ping her today that you want to provision your lab, right? You want to have access to the labs, and then she will talk to me, and then I will let her know that okay, what needs to be done.
Okay.
So there is a
All right.
process in place, but you just have to let them know that you are looking for having the lab access. So Jordan, you can also do same.
Okay, I have EVNG at my house, a server with EVNG, but I can I'll do that as well.
Okay, okay. So if you already have the EVNG, so that's what we are also. So this is what I am also going to access, the EVNG. So just hold on, please. So if you already have the EVNG, then it is okay. But still, if you want to have the access to the labs which are hosted here in our environment, you can go ahead and ask your account managers to provision an account for yourself, right? So I'm creating a new lab for you, a brand new lab, right? So let me just put it CCNP, CCIE, switch. I'm gonna pick a couple of switches here, and I'm gonna pick 9000 V series of switches, you see? So even I have got Catalyst 9K series of virtual switches. Let me see if those boots up. And in my opinion, yes, those switches must be booting up successfully without any problem. And let me have like 4 nodes here. I'm going to assign like 8 CPU cores to each. This is how the Catalyst 9K series of switches will look like. So switch number 3 and then switch number 4. I can make this type topology as well. Switch 2, 3, and 4. Let's make the connections now between switch 1 and 2. Again. Oh, come on. I have to delete this because that's management board probably. Okay, 1 by 0 by 2, 1 by 0 by 2. Yep. Switch 1 to switch 3, 1 by 3, 1 by 3. I'm using same interfaces, same port IDs at both ends. 1 by 4, 1 by 4. And then switch 1 to switch 4. One more connection. Then connection between switch 2 and switch 3. One by 0 by 5, and then 1 by 0 by 6 at both ends. So I'm using like same interface ID so that it would be easier for us to understand the connectivity. Okay. I hope everybody is comfortable with this connectivity. Ashish, Jordan,
Yes,
Shakil.
sir.
Good. I'm gonna go ahead and connect a PC to this switch now. So Windows operating system. I'll connect this PC to the switch now here on its gig 1/7. I might have one another PC connected to the same switch, let's say. There you go. It's done. Let's power on our topology now, and then we will start working on our labs as well at the same time. So you should have access to the labs, or you can ask your account managers to help you out to build labs on your own laptop. So we have a dedicated person who can really help you out to set up the lab on your own devices. So it's up to you how you want to proceed further with the labs. But anyways, after all, you should have an access to the switching lab like this. So like having at least 4 switches in your lab topology, and then a couple of let's say PCs and 1 or 2 routers, and that should be sufficient. Currently, I do not have any router over here, but yeah, I could also add the routers. Like for an example, if I'm using Catalyst 8K series of routers, 8000V, I do have it 1000V as well, but that's okay. So like 8000V, which is the latest series of router, right? And yeah, I could have that as well. So minimum, I need one router to perform all the labs that we are supposed to perform here. So I could make a connection between switch 4 and 8K series of router. And then I also could have like one more router if needed. But anyways, for now, it's not really needed. Let me just go ahead and delete this. For now, having 4 switches is more than sufficient. Let's have the console access now for this switch. Hmm. I might have to wait for a little longer then. I'm not getting any response from the console. Meantime, let me also have access to the other lab. So at least I can perform the lab for configuring switch port, or disabling switch port, and so and so. So if you look at this switch now, right, it is a layer 3 switch. And currently, if you look at here, show interface gig 1/2, and then put the switch port keyword to see if this is a switch port, like if this port is a layer 2 port or a layer 3 port. If it says switch port is enabled, that clearly indicates, or that would validate here that it is a layer 2 port. So as I told you before, that by default, all ports are switch ports. However, if you want to change that, you can. For an example, if you wanted to set this up as a layer 3 port, go to global config mode, go to gig 1/2 like this, and then say no switch port. As soon as you put this command now, the state of this interface would get changed. Now it must be a layer 3 port. How do I identify that? Or how can we identify that? There is a command, show interface gig 1/2 and then switch port. If switch port is disabled, so that clearly indicates that it is a layer 3 port now. The advantage of configuring this port as a layer 3 port would be that now we can assign an IP address on this interface. For an example, interface gig 1 by 2 and then say IP address 191.68.10.99 or whatever, right? /24. This is how we could allocate an IP address on this interface itself. So IP interface brief. So it's like router now. Look at this. It's like a router. And then if you want to make it back as a layer 2 port, fine. It's so easy. We could do that. But I would like to show you a couple of things here before I do so. Like I will convert this back to layer 2 port, which is fine. Because finally I want to utilize this interface as an access port, because that goes towards my lane user machine and that should be part of the VLAN 10. Fine, I can do that. But before I do that, I would like to show you a couple of more things. So you know that currently this interface is working as a layer 3 interface. So you could also run this command, show IP interface gig 1 by 2. So it would display you all the information like this, right? Like a normal layer 3 port. If you look at the other interface information, so it says that inbound access list is not set or whatever. I mean, what it is trying to say, but you would not get anything in the output of this command. Or you could run this command like show interface gig 1 by 3 and then switch port. So it will show you that yes, switch port is enabled, which means it is a layer 2 port. Now, if it is a layer 2 port, then it cannot be a layer 3 port. It cannot have an IP address. So if you try to assign an IP address now, like on gig 1 by 3, say IP address 12.1.1, like even you can type the entire command, the complete command, 12.1.1/24, let's say. It will not accept your command because it is a layer 2 port. Since it is a layer 2 port, you cannot configure any IP address on it. You know that I have converted one layer 2 port as layer 3 port, right? You know that on interface gig 1 by 2 particularly. So if I run that command again, so it says switch port is disabled. Yes, that is a correct statement. You know, when you disable a switch port on the layer 3 switches on any interface, what it does in background, it creates an extended VLAN, right? It creates what? An extended VLAN. So if you say show VLAN brief, do you see an extended VLAN here? I don't see that. I've got only default VLANs here, right? But you would not see interface 1 by 2 member of any VLAN now. Do you see that your interface 1 by 2 is member of any VLAN here? No. Why? Because it is a layer 3 interface now. And layer 3 interfaces are not member of any VLAN by default. But in background, as I told you, that when you disable the switch port on any interface, it creates an extended VLAN. And to see that, the command would be show VLAN internal uses. That's the command. That for internal uses, has it created any VLAN? That's the command syntax. So you could see that on gig 1 by 2, it has created VLAN 4094. Do you see that VLAN? Ashish, Jordan, and Shakil.
Yes, sir.
You see that extended VLAN which has been created automatically by our switch. So I wanted to tell you that when you disable a switch port any interface, then in background it creates extended VLAN and it maps that interface into that extended VLAN. And this is what exactly it has done. So in short, whenever you allocate this IP address on your physical interface here, like we have allocated this IP address physically, right, on physical interface. But technically, it has got allocated on VLAN 4094. You see that? Because, I mean, generally on switches, you create SVI. Now, what is SVI? Switch virtual interface. So when you allocate an IP address on a VLAN, then you call it SVI. So in this case, like in this situation, in this example, I never created SVI manually. But if you look at its internal process, then it's clearly, it's clearly mentioned, or it clearly indicates that yes, it was a SVI, switch virtual interface, that it has created. Although we allocated IP address on the physical interface, but in backend, your IP address is allocated on this VLAN 4094, and this interface is mapped to this VLAN 4094. And I would like to show you one more thing. Like if you go ahead and create a VLAN 4094 now, like 4094, you try to create that VLAN. So let's say name is test, or maybe I-MED or I-MEDITA, and then say exit. Is it creating that VLAN? Has it created that VLAN? No. Clearly no. It says failed to commit extended VLAN changes. This VLAN is not available in port manager. Why? Because this VLAN is already in use on this interface. Is that clear? So
Yes,
don't
sir.
you think that it has proved that in background it has created the SVI? It has allocated that IP address to this VLAN only. However, at front line, it seems that the IP address is directly configured on the physical interface. But no. One more thing that I would like to bring up, which is like this time we saw that it created a VLAN 4094. So it started from the end. And then if I go ahead and make one more interface as my layer 3 interface, let's say interface gig 1 by 3, and if I say no switch port, and then if you look at here, another VLAN will be created 4093. So it is following the descending order. Which order it is following here? Descending order. It's not following an ascending order for creating VLAN. It's coming from top to down. But generally, you start with the lower number and then goes towards the higher number. That's ascending order. So you know why it is happening? Because I have changed it. So in fact, if I show run config here on this switch, you would see that I have enabled a command here. See, I've told my switch to allocate VLAN in descending order, not in ascending order. That's the reason. But if I change it, let's say if I say VLAN internal allocation policy and then ascending, not descending, that's a default one. This is the default one, ascending order. Now I'll do one thing. I'll go back interface gig 1 by 2 and I'll make it switch port again. And then I'll go to gig 1 by 3 as well. And I'll make it switch port again. Now, once I make them switch port, those two interfaces are supposed to be an access port. Here you could see that 1 by 2 goes towards this PC. 1 by 3 also goes towards that another PC. So those are supposed to be part of the default VLAN 1 by default. Show VLAN brief. Look at here. Those are in VLAN 10 actually. Okay, got it. Because I must have put them in VLAN 10 in past, right? So that's the configuration that it has activated. So both interfaces are member of the VLAN 10. So which means that those two interfaces are now layer 2 port, not layer 3. Because if they were layer 3, then I must not see them in this output. If any port is configured as layer 3, then I must not see those interfaces as part of the output of this command, right? So I'll do one thing now. I'll go back to gig 1 by 2 and I'll say no switch port. And then I'll move on to gig 1 by 3 and again I'll say no switch port. And this time, again, these two interfaces have become layer 3 ports. So if I say show VLAN brief, I must not see any of those two interfaces here in this output. I don't have either 1 by 2 or 1 by 3 interfaces listed out here. I don't see those two interfaces. Why? Because I have converted them from layer 2 to layer 3. However, if you look at the internal uses VLAN now, understood this?
Yes,
This
sir.
time they have started. Again, those are extended VLAN, but starting with 1006. Because until 1005 is unsupported here. And then your extended range of VLAN starts with 1006. And that's where it has got started now. Okay. I'll go back to gig 1 by 2 and then I'll just say switch port again to make it layer 2 port back. And then again switch port command. And that's it. All right. Let's go back to PPTs now. So I hope that all of you have understood this whole stuff now. I've already told you that when you create, when you apply this command, no switch port, in background, it will reserve an extended VLAN. And that range starts from 1006 to 4094. By default, it uses ascending order. However, you can also change it to the descending order. Okay. So it's up to you. It will bind that physical port with that VLAN logically. And generally, it is not shown in the VLAN configuration. Like when you say show VLAN brief, or maybe you are trying to look at the running config, you would not see that interface anywhere or that VLAN. It will disable all layer 2 protocols. Like when you convert your port from layer 2 to layer 3, then no STP packets, no DTP packets, no VTP packets will be processed on that physical interface. So that interface will stop participating in STP. Switch will never send any DTP packets out of that interface. Switch will never send any VTP packets out of that interface, because those protocols will get disabled on that interface, which you have converted from layer 2 to layer 3 now. And as I told you in background, it assumes a SVI for that extended VLAN that has been created in the background, right? This is what I already explained to you. Okay. We could see if your VLAN is, which VLAN has been created and assigned to that layer 3 port. And the command was show VLAN internal uses. We have already used this command, so that should be okay for all of you. And then after, if you try to create the same VLAN which has been created, then it will give you a error message saying that this VLAN is already in use and cannot be created. You could change, as I explained to you, that by default, your switch will be creating extended VLANs for your layer 3 interfaces in ascending order, but you can also change it to descending order. So this is what we did, and we have seen that. Switch virtual interface. Now let's talk about the SVI. So, rather putting or rather changing your physical interface into, from layer 2 to layer 3, it is also possible that you can create layer 3 interfaces using SVI, switch virtual interfaces. Okay, so what is the SVI? Let's see that. So for an example, now, you could see that my interfaces are part of the VLAN 10, like gig 1x2 and 1x3. My diagram has these two machines, and let's assume that both of them are in same VLAN 10. Let's also make sure that they both have the same, the IP address from the same subnet. So one of them, let's say, having 10.10, the other one is having, let's say, 10.20. Okay, so PC1 should have an IP address called 10.10. Let me check that out. Yeah, 10.10. And gateway is 10.1, which does not exist anywhere actually. The other PC, the IP address should be 10.20. Okay. And then let's assume that gateway is 10.1. Now, gateway does not exist because gateway was never created. But yes, we can create that gateway on this layer 3 switch. So you go to layer 3 switch. And for VLAN 10, we could create the SVI over here. So we know that these both interfaces are member of VLAN 10. But I don't see any IP address allocated or created for VLAN 10 here. So I could do one thing. I could go to VLAN 10 like this, interface VLAN 10, and then allocate IP address. So for an example, I wanted to allocate 10.1/24. No shutdown, and that's all. This is how you create SVI. This is called SVI, switch virtual interface. When you assign an IP address to your VLAN interface, that's called SVI, switch virtual interface. Okay, so now remember, on layer 3 switches, you can create as many as SVIs you want. Like obviously there is a threshold as well, but many SVIs can be created, and all those routes can be installed in the routing table as directly connected automatically. And also you can enable dynamic routing. But on layer 2 switches, like if you had a layer 2 switch, let's say 2950, 2960 series of switch, on those switches, you cannot convert your physical ports from layer 2 to layer 3. That's not possible. However, you can create SVI on layer 2 switches, but you cannot enable routing. Like here on this switch, I can say IP routing because it supports routing. But on layer 2 switches, you cannot run this command. So on layer 2 switches, what we do is we create SVI for the management VLAN. So let's say you dedicated one VLAN as a management VLAN in your environment. So for that management VLAN, create SVI on your layer 2 switch and also configure the IP default gateway using this command. So you can also have access to your layer 2 switches from remote locations. So that's the only purpose of creating SVI on your layer 2 switches, so that you can access them remotely. You can configure them remotely. And just in case if you're looking to upgrade and all that, then you can also copy paste, the images using FTP or TFTP protocols, right? So that's the advantage of allocating an IP address on layer 2 switches. So on layer 2 switches also you can create SVI, but remember that only one SVI can be activated at one point of time. You can't create SVIs for multiple VLANs on layer 2 switches. However, on layer 3 switches, yes, it's possible. Like I've created the SVI for VLAN 10. I can also create for VLAN 6, like it's already there, I believe. So let me show you that. Okay. Show IP interface brief. Look at this. So it has SVI for VLAN 6. Like I had that IP configured on VLAN 6, and I just recently I just configured an IP address on VLAN 10. So I've got like two different SVIs, and both should be active at same time. And in routing table, both SVIs should be available. And yes, you could see that both SVIs are available in the routing table of this switch. So this is how you could create the SVI. Now from here, I could try to ping like 10.10. That's PC1, and then I could also try to ping 10.20, which is PC number 2. So both PCs must be reachable. In fact, if you go to any of your PC, this is PC1, and if you go to command prompt, say ipconfig, so this is my IP address, and then if you want to try ping 10.1, it should be pinging. And then if you look at the ARP table here, so ARP-A, look at the MAC address for 10.1. So that's five zeros then 1, then 800A. And then if you go back to your switch here, say show interface VLAN 10. So what is the MAC address of this interface? And exactly same MAC address is displayed by that PC in its ARP table. Does that make sense?
Yes.
Yes, sir.
Good. So this is how you can create SVI on your switches. I don't think that you would have any issues while creating SVIs, but yeah, on platforms, if you read their white papers, if you read their data sheets, then you would get to know that each platform has got a limit on their maximum number of SVIs that you can create. Like somewhere you would have that you can create up to 200 SVIs or maybe 500 SVIs or maybe 1000 SVIs. But again, it will be it will vary as you change your platform. Okay, so different platforms will have different capacities. Okay, cool. So this is about the SVI, switch virtual interface. So that has been created now. So generally on layer 2 switches, you would do it only for management VLAN, but yeah, layer 3 switches, like you can create SVI for many different VLANs. And we do that basically, like, I don't know how many of you are already working, but if someone, is already working, you could take a look at the core switches, and on core switches, you would find so many SVIs created, or maybe distribution switches. The next protocol that we're going to talk about is CDP, and then let's talk about the LLDP. So CDP, Cisco Discovery Protocol. That's the full form of CDP protocol, Cisco Discovery Protocol. So as its name indicates, Cisco Discovery Protocol, which means that you can use this protocol for device discovery. Who is connected where? So if you have all Cisco devices, then by default CDP is enabled, and you can go back and run this command as well. Like for an example, if you want to check if CDP is working, just run this command, show CDP neighbor. So this switch is telling me, like, if I read this information properly, so I got this information that I have switch 4 connected on this local port. This is my local interface 1/0, and this is remote port ID. This is remote interface ID. Like on switch 4, I have got this interface 1/0. So my local interface 1/0 goes towards switch 4, and it's connected on 1/0. Now, what is the capability of this switch 4? RSI. R stands for routing, S stands for switching, which means that it can perform routing, it can perform switching, and I says IGMP capable, which means that it can also support multicast routing. Okay, so that's the meaning of capability. For how long it will keep this entry in its CDP neighbor table? 171. However, the default CDP hello interval is 60 seconds. So after every 60 seconds, it will keep on receiving CDP packets from its neighbor devices. So this timer, like now it's 162, but then it will get resetted automatically. 158, 156, you would see that it will get reset automatically. Because in every 60 second, you are supposed to receive the hello packet. So it's 145 now, 143, 141, 139, 136, 34, 31, 28, should go up to 120. And then back to 178. Because 180 seconds is the hold timer. And then 60 seconds is hello interval. So in every 60 seconds, we are expected to receive the CDP hellos coming from the neighbors. Okay. So CDP is by default enabled, but the problem with CDP is that it is a Cisco proprietary protocol. But again, it is helping us a lot because it is giving us, like for an example, you joined some company, some organization, and they don't have any diagrams. Nobody created any diagram, Visio diagram to, to see that like how connections are made, how connections have been made between the devices. Then it is very difficult for you to perform troubleshooting. So, what I do is, if I join a organization where I don't have diagrams, then I go and create those diagrams. And usually I use CDP and LLDP protocols. CDP is by default enabled. You don't have to do anything for CDP. You want to disable CDP or you want to change timers? Let's change timers first. So CDP timer, and then you could see that the packet rate, right? By default, CDP interval is like 60 seconds. And in fact, we can see that if I never changed it, if I would have changed it in past, no, it seems that I never changed it. Show CDP. Show CDP. That's the command. So if you look at this, CDP packets are sent in every 60 seconds and hold down interval is 180 seconds. You want to change that? Fine. You go ahead and change it. So CDP timer 30, CDP hold, let's say I want to make it 90. Fine. Okay. So now my switch will send CDP packets in every 30 seconds and I'm going to wait for my neighbors for maximum 90 seconds. If I don't receive any CDP hellos from my neighbor until 90 seconds, then I will remove those entries from my CDP neighbor table. So if you look at here, show CDP neighbor, this is how you could look at the neighbor table. Okay, but this is how you could change the CDP timers. Like if you say now show CDP, so the timers have got changed now. If you want to disable CDP completely on your switch, then the command is CDP no CDP run. That's the command. Now if you say show CDP neighbor, it says CDP is not enabled. So this is how you could globally disable the CDP. You want to enable it back, say CDP run. And if you say show CDP neighbor now, obviously it should start updating the CDP neighbor table. So it has got switch 2, but sooner it will have switch 3 and 4 all. So this is how you could globally enable and disable CDP on your switch. But it is also possible to enable disable CDP on interface basis. Like for an example, if you go to gig 0x0, you want to disable CDP only on this interface, then use this command, no CDP enable. To disable CDP on this interface, you want to enable it back, then say CDP enable. So it's so easy to enable, disable CDP globally or to enable, disable CDP on per interface basis. And again, it will be depending upon your requirement, like what you want to perform, what do you want to do. But this is how you do that. Now, the biggest problem with CDP is that it is a Cisco proprietary protocol. That's the biggest problem, right, with CDP. And to fix that, we have another protocol called LLDP, Link Layer Discovery Protocol. It does same as CDP. I mean, it also does the same thing as CDP does. And the biggest difference would be the interoperability support. So if you want to have interoperability, for an example, at one end you have got Cisco devices, at other end you have got, let's say, for interoperability, like as I mentioned, that at one end you have got Cisco devices, at other end you have got Juniper, then you can't use CDP there, right? CDP will not be working. So in that case, the only option you have got is the LLDP. So let's learn that how we can enable the LLDP now. It's pretty much simple. Again, it's not that difficult. So let's say I'm on switch one. So you could say LLDP run to enable it globally. To disable it globally, say LLDP no LLDP run. But remember that on Cisco devices, LLDP is by default disabled. So you will have to get it enabled by running this command, LLDP run. Now LLDP is enabled. So if I say show LLDP neighbor, LLDP neighbor, do I have anything there? No. Why? Because I don't have LLDP enabled on other switches. So if I go to switch 2 now, say LLDP run and then say show LLDP neighbor. I must have switch 1 and 2 entries now. I must have entries on switch 1 and 2 respectively. So if I say show LLDP neighbor now, do I have my interface is shut down? No, those are up. I must see entries for my LLDP neighbors. Show interface gig 0 by 0. Come on. I know I might get some different outputs here because Ether channel is already in place, UDLD is running, so maybe LLDP is getting struggled over here. So if I reset my switches, LLDP would start working perfectly fine. But let me show you that how you could do that, right? So LLDP run is the global command, but if you want to implement LLDP on interface basis, then go to interface and then say LLDP transmit, LLDP receive. Or you wanna transmit LLDP packet, but you don't want to receive them, then say no LLDP receive. Now this feature is not available with CDP. Like in CDP, either you can enable it on interface or you can disable it. But with LLDP, you get flexibility that you can say that I want to send LLDP packets, but I don't want to receive, or maybe I want to receive LLDP packets, but I don't want to send LLDP packets. So this is also something that you can do with LLDP. You can also modify the LLDP attributes. So like LLDP TLV select, and then it should have this information, like if you want to have a management address within that, although by default it is added there, so you don't have to add it manually. But if you want to exclude some information, if you don't want, let's say, your LLDP to carry the management address, then just say no LLDP select management address, so that it will stop carrying the management IP of your device into LLDP packets. Because when you say show CDP neighbors detail, then it will give you a detailed information, like even the IP addresses of your neighbor devices, the management IP. So that information can also be displayed here. The VTP domain name and the management IP and so and so. So all that information can be displayed. If I say show LDP detail, so you can get the detailed information. But currently it doesn't have any entry. Why? Because the virtual switches are not behaving as expected. Usually LLDP should have worked here. But as I told you that I have Ether channel configured, I have UDLD enabled, and probably that's one of the reason that LLDP is not working as expected. Okay. Anyways, I have already told you that how to enable LLDP, how to activate it, like how to enable it globally, and then how to get it enabled on per interface basis. And then also I have told you the major difference in between CDP and LLDP. So remember that LLDP is a open standard protocol, and you would be using LLDP for interoperability. Okay. All right. The next is campus network design. So generally we use any of these two models or these two types of designs. One is called three-tier hierarchical model, and second is called two-tier hierarchical model, where you have got only access layer and core and distribution layer are combined together. Whereas with three-tier architecture, you have got access layer, distribution layer, and then core layer. So let me show you first of all, let's try to understand the meaning of access layer. So access layer switches are those switches where you would be connecting your end user machines like laptops, desktops, or maybe printers, IP phones, cameras. So all these sort of devices like your coffee machine, and then your end devices will be directly connected on access switches. So the access layer exists where the end users are connected to the network. Access layer switches usually provide layer 2 connectivity between user and devices in layer, sometimes called building access switches. They should be having following capabilities like low cost per switch port, which means that switches should have the higher port density. That's how you can reduce the cost per port. Higher port density, of course, I have already told you, and scalable uplinks to higher layers. So they should have like uplinks. They should have uplinks. Then high availability and port security should be supported by these switches. Ability to converge network services such as data, voice, and video should be supported. And the layer 2 quality of service. Layer 2. Generally, we do not configure layer 3 quality of service on access layer switches. But yeah, layer 2 quality of service should be supported by these switches as well. So that's the expected capabilities that access layer devices, access layer switches should have. Then let's talk about distribution layer of switches. This layer provides interconnection between access layer and the core layer. Devices in this layer are sometimes called building distribution switches, and distribution switches are layer 3 switches. They should have the following capabilities like the aggregation of multiple access layer switches, higher layer 3 routing throughput, obviously, because these switches will be responsible to perform the routing, and then security and policy based connectivity functions, QoS features, and scalability, redundant high speed links to the core and access layer switches, which means the uplinks should be supporting like higher bandwidth. The core layer are high-end devices that you should use as a core layer switches, should be able to do or to perform mostly everything except NAT, because generally NAT is performed on firewalls or routers, not on switches generally. So this is how the three-tier architecture will look like. So you could see access layer, then distribution, and then core layer. So this is how we do it. And generally, if you look at the build, here is the building. So you could see that we are using three-tier architecture for this campus. So let's say you have got a campus where you have got multiple buildings. So within each building, you would have access switches, distribution switches, and in any of the building, you would have your core switches. So all buildings will be connected to that centralized building. In centralized building, you would have core switches. Then and other than that, each building in the campus is going to have access switches and distribution switches. Usually, access switches are placed at each floor, whereas distribution switches are placed at one floor in one building. That's what happens. So it's up to you. Generally, nowadays you would see this two-tier hierarchical model in most cases. We don't use three-tier architecture anymore. And in fact, with SDA Fabric, we are not following that. We are just following the two-tier architecture. Nowadays, it is recommended that even your access switches should be layer 3 switches, not layer 2. And once you go for the Cisco SDA Fabric, like obviously you have got a dedicated training for Cisco SDA. And that's where you would be learning that the interswitch links would become layer 3, and there will be a routing enabled between the switches, even in between access and core, because there is nothing like distribution anymore. So that's that. And the next chapter is like switch operations, like what are the functions of the switch, what all functions that a switch performs, right? So that's what we're going to start with. But I want you to go through this, these PPTs once, and then I'm pretty much sure that you would have questions around it. And if you have any questions, come back and discuss them with me. I will explain that in more detail. But generally, like in early days, we had this type of architecture or this type of model that we always followed. So that was a three-tier architecture. So core, distribution, and then access. This is how we make the connections. So all distribution switches are connected to the core, and as well as downward connected to the access layer switches. All access layer switches are connected to both of the distribution, and then both of the distribution are connected with both of the core. So if you look at this design, generally this design is made in such a way so if one of the switch completely goes down, still there is no impact on your end-to-end connectivity, which means that there is no single point of failure. We also perform multi-chase ether channel, but that topic will come later. I believe that that's in the end of this training. That's where we will be talking about the multi-chase ether channel. But now I'm not going to talk about the multi-chase ether channel. The functions of a switch, right? That's the very next topic or next chapter. But that's something that we're going to start tomorrow, not today. The operations of switch, like what all things are performed by a switch. That's something that we're going to learn tomorrow. If anybody has any questions so far, don't hesitate to ask.
You said that we don't use three-tier architecture
Anymore. Yep. Because now we are moving towards the SDA fabric. And in SDA fabric, like we have only core switches and then access switches. And all access switches are layer 3 switches. And between access switches and the core switches, you are running layer 3. You're not having dependency over trunk or STP anymore.
You said that there will be SDA discussion. So is that covered in switching or
no,
routing?
not in switching. SDA is a totally separate module. If you are enrolled for CCIE training, then you would have a dedicated training for Cisco SDA.
Okay.
Like SD-WAN. So there are two different technologies that are becoming more and more popular nowadays, and everybody is moving or migrating over to those SD-WAN and SDA. So those are SDN-based technologies, software-defined networking. So if you are enrolled for CCIE, then you would be covering SD-WAN as well as you would be covering SDA. But earlier, if you talk about 3-tier architecture here, we used to have 2950 series of switches or 2960 series of switches. At distribution, we used to have like maybe 3500, 3700 or 3600 series of switches. At core, we used to have either 4500 or 6500. If you had no money, like if customer had not much money, then they were using like 3500 or 3600 series of switches at core as well. That's what it was. Anyways, let's meet tomorrow at same time, right? And we'll continue with the functions of a switch, right? So I would suggest you, because all of you have already gone through the CCNA training. So all of you have some basic ideas about the switch. So please go through that. Please go through those PPTs in advance before you join tomorrow's session, so that you can ask me more questions. You can have the interactive sessions. So that's that. Okay.
All right.